Rahim. This is problem number 11 from the problem set number 6. This is a problem in which we have to find the electric potential at point 101 because of the two charges minus 4 microcoulomb and 5 microcoulomb located at these 2 points, located at this 2 minus 1 3 and 0 4 minus 2, assuming that the zero potential at infinity. So the potential at infinity is 0, which means that we have to find the absolute potential due to the 2 points and add them. So there are two potentials, and so all we need to do is to find the distance between the 2 minus 1 3 point and 101 and 0 4 minus 2 point and 101, and then use this formula to find the potential and then add them. So it's a relatively easy problem. We have, let us draw the the 2 points. So I have one point at 2 minus 1 3, which is this point here approximately. This is, I call it Q1. 2 minus 1 3, and the charge here is minus 4 microcoulomb. And there is another point which is 0 4 minus 2. So 0 4 minus 2, which is around here. 4 minus 2, we call it Q2, and the charge here is 5 microcoulomb. And this is my origin, and I need to find the potential at point P, which is 101. So 101. So what I do is I just join these 2 points. So this is my 101 point. So I join this point and I call it R1, and I join this point and I call it R2. So, and I can, and the potential is at point P, this point is, so potential I call it VP is equal to Q1 divided by 4 pi epsilon 0 R1 plus Q2 divided by 4 pi epsilon 0 R2. And this assuming that V equal to 0 at infinity. So this is very important. So this is, I know that this factor is 9 multiplied by 10 raised to power 9. So I just take a common factor, 9 multiplied by 10 raised to power 9. Q1 is minus 4 microcoulomb divided by R1. Let us calculate R1 and R2. So R1 equal to 2 minus 1 square plus minus 1 minus 0 square plus 3 minus 1 square and square root. So that will be 1 plus 4 square root. That will be 6 square root. And R2 is equal to this minus Q2 minus P, so it is 0 minus 1 square plus 4 minus 0 square plus minus 2 minus 1 square, and that will be 1 square plus 16, so 1 plus 16 plus 9 square root, and that will be 26 square root. So I come here, I write square root 6 plus 5 microcoulomb divided by square root 26. So I do this calculation, and my answer comes out to be minus 5.8 multiplied by minus 5.87 multiplied by 10 raised to power 4. So that will be 1 2 3 4, so it will be 5 50, so that will be minus 58 kilovolt. That will be Vp. Now this is assuming at V equal to 0 at infinity. Now we have another problem, just for the sake of understanding, that if voltage at infinity is not equal to 0, but the condition is if voltage equal to 0 at 0 0 0. So this becomes another problem in which we have to use the constant. So in this case I have, let us draw it once again. So I have this point q1 2 minus 1 3 and q2 0 4 minus 2, and the origin at this point the potential is 0. So I have to first calculate these two distances. So I call it R01 and R02, and then I have to find this constant. So the voltage at any point is equal to, or at this point P, I call it P, is equal to this R1 and this R2. So this is point P, the same point P is equal to VQ1 divided by 4 pi epsilon 0 R1 plus Q2 divided by 4 pi epsilon 0 R2, and I need to add a constant. Now this is, I already know from the calculation above, this is minus 58 kilovolts. But to evaluate the constant, I need to find the voltage due to voltage at V0 and make it equal to 0. So then I can find the constant. So what is V0? V0 is the Q1 divided by 4 pi epsilon 0 R01. In this case I have to take these two distances from the origin. So this will be Q1 divided by plus Q2 4 pi epsilon 0 R2 plus C. This is the same C, but this will be equal to 0. So from this I can find the constant C. Now what is in this equation? I know everything except R01 and R02. So I calculate R01. That will be 2 square plus minus 1 square plus 3 square root, and that will be 4 16 plus 1 7 plus 9, so 26 square root, and R02 will be equal to square root 0 minus 0 plus 4 minus 0 square plus minus 2 minus 0 square, that will be 16 plus 4, so 20 square root. So now my V0 will be equal to, I again take this common factor, 9 multiplied by 10 to the power 9, Q1 which is minus 4 microcoulomb divided by R naught 1 square plus 5 micro divided by 20 square root, and plus C equal to 0. So C will be equal to minus 9 multiplied by 10 to the power 9, and I take it to the other side, so it will be minus, so everything will become minus, and that will be minus 4 micro divided by 26 square root plus 5 micro divided by 20 square root, and that will be, if I calculate this comes out to be minus 4.4 kilovolts. That is my C. Separate this from here. So C equal to, because this is equal to 0, so C will be equal to this. So now I can calculate my Vp, that will be Q1 divided by 4 pi epsilon 0 R1 plus Q2 divided by 4 pi epsilon 0 R2 plus C. And this I know it is equal to minus 58 kilovolt. So it will be minus 58 kilovolts and plus minus 4.4 kilo. So that will be equal to approximately minus 63 kilovolt. That will be my Vp. And that is if V naught equal to 0 at 0, 0, 0. So we have, now in this case we have two sort of problems. So in the second type of problem we first need to find the constant. And to find the constant we assume V0 equal to 0 at origin, and then we can just find the constant, this constant, which is equal to this all comes on the other side, so this all becomes negative. So this is how I can find. Now this is not included in the problem set, but this is a very important problem and it can come into the exam anytime.